When looking on the lessons we just went through, the samplers and drum machines, synthesizers have a lot in common with them, mostly the modulators as envelopes, LFOs, low frequency oscillators, and filters, effects, and such. But in a synthesizer, the sound producing engine is actually producing sound on the spot. So producing a sound using an oscillator, which is this. So we have one discrete oscillation of a sawtooth waveform, which is being repeated in a certain speed to achieve a certain frequency to coincide with the note that we actually sent to the synthesizer. So if we send the note C, it will play this oscillator in that frequency. Now with the synthesizer, especially one complex as Serum, we can change that oscillation. It would sound different. We have many more controls over that oscillator. So using synthesizers gives us much more freedom in sound design. But let's go from the top. We have oscillator producing the actual sound. We have a filter filtering the sound. Let me demonstrate that for you. So let's say a low pass filter like this one. You can see the filter shape. This is our spectrum of frequencies we are producing from 20 Hertz to 20,000 Hertz. And this is the filter cutting off all the frequencies above a certain point, a point that we determine. And we can see that's 370, 410 Hertz. So let's hear how that sounds. So you have various different filters, oscillators, producing sound, filters filtering those. And then we have modulators that actually modulate any of the parameters we need. And as I've told you, we have the envelopes, which are actually connected to our note on and note off messages being sent by MIDI by pressing notes. And we can, for example, use that envelope, let's say envelope number 2, to control our filter positively, of course, moving filter positively in time. So right now, I've told you in the lesson before, we have attack, decay, sustain, release. Now in this envelope, we have this one extra step called hold. And we will talk about this in our sound design course. For now, it's very important for you to grasp this main concept of an envelope, which is ADSR, attack, decay, sustain, and release. I think it's much easier to explain these when we have a nice graphical display of those so that you can actually see what happens when we press a key and when we release it, also what happens. So we have this sound, we have the filter on it. Let's see what happens with the sound with an envelope set like this, controlling our cutoff frequency. You might have guessed it. So once I press the key, first the attack happens, then the decay happens, and then the value of the cutoff will be held at sustain level, which is right here 50%. So 50% between the minimum and the maximum value. It's going to hold it right there all the time until I let go of the key, and then the release time is going to happen. So we have 3 time values: attack, decay, and release. Those are all time-based values. And we have the sustain, which is an amplitude value that tells the envelope where to hold after the decay has actually elapsed, where to hold the value of the parameter while we are holding the key. We cannot hear the release happening. Why? Because the envelope controlling the amplitude of the oscillator, which is here by default envelope 1, has no release. So the sound stops before we can actually hear this release happening. So let's change that. Let's give more release on this original envelope of amplitude so that we could actually hear what happens with the filter. See, we do have it. So it does sound okay. We can manipulate also its shape. Also notice that you can actually see when I press the note and when I let go of it. So we have envelopes that control parameters, and they are closely related to the note on and note off messages we are sending to the synthesizer. We also have LFOs, and those are low frequency oscillators. Oscillators, just like the ones we mentioned in one of our first lessons, they just oscillate in a shape pre-given. Let's say this one was a triangle shape, if you remember that. So it's going to oscillate like that, but it doesn't actually produce sound as a normal oscillator would. It's a low frequency oscillator, and it would just control any of the given parameters by oscillating up and down. So let's turn this one off on the filter so you can actually hear this one at work, the LFO. Let's slow it down. So you can actually follow the line and see how that is affecting the parameter going up and down. So imagine we have 3 envelopes, 4 LFOs, and more to be added once we use all of them. We can use these to control any of these parameters. We can use LFO1 to control another parameter at the same time, or all of the parameters at the same time even. With this, the complexity of sound design is unparalleled. Now, of course, there are more things that you could control using MIDI messages. Let's say velocity, the strength at which you press the key could control one of these parameters. It could be anything you choose. So anything could be dependent on that velocity, on that strength of how you press the key. So let's say volume of the actual oscillator could be dependent on that. So now if I do that, dependent on how hard I press the key, on what velocity I send with the note, the level is going to act accordingly. So for higher velocity, the oscillator is going to produce a higher level signal, higher amplitude signal, and lower velocity, lower amplitude signals. I can remove any of these modulators on any of these parameters. Of course, note can also play a role. So let's say a higher note can produce a higher volume sound, higher amplitude sound, and the lower note can produce a lower volume sound. Let's say a lower note. You see the volume is right there at this really blank blue dot right there showing us. And the higher one, an even higher one, even higher. So the height of the note pitch can be one of the controllers for any of the parameters inside the synthesizer. And of course, the last thing within any modern synthesizer is actually the FX section. We can affect this sound, a plethora of effects, and each synthesizer has different ones. In Serum, we have different ones like a flanger maybe. Let's try that out. Maybe a phaser. We have distortions, which makes it really loud. We have some delay, compression, reverb, and we can change the order of these effects. So we want the compression before the delay and reverb. See the repeating of the delay. Maybe some reverb instead of that. An EQ, another filter on top of all of those. Of course, we can change the order of these. So quite enough sound design tools, as you can see, are present in this synthesizer. From what you could deduct in Ableton, we could use any of the native or third-party plugins to achieve the same thing using plugins from Ableton or even using Serum. So I could, as a matter of fact, use any of these effects and couple them with serum using flangers, gates, equalizers, and just pairing those together, making one instrument, saving it as one instrument, giving it a name. So a plethora of combinations can be made. Using internal effects or external effects is just up to you and your choice of what sound you like.